Hi, this is Mrs. LaBarbera. This is AP Physics Mechanics C. This chapter is chapter 6, which talks about work and the kinetic energy relationship. So here is an example from 2003 AP exam number 1 in Mechanics C. So the question says, a 100-kilogram box is being pulled along the x-axis by a student. So the box slides across a rough surface, and its position x varies with time t according to this equation, x equals 0.5 t cubed plus 2t, where x is in meters and t is in seconds. Question A, determine the speed of the box at time t equals 0. Since we know x, the displacement as a function of time, we can figure out the speed because speed is just derivative of position over time. So in this case, v equals dx over dt. That gives us 0.5 times. Remember, you bring 3 forward, then you decrease the power by 1. So 3 times t squared plus 2. This is bring the power 1. And subtract 1 minus 1 is 0, t to the 0 is just 1, so that gives us 1.5 t squared plus t. To determine the speed of the box at time t equals 0, we simply substitute t equals 0 into this expression. We get v equals to v at 0 second equals to 2 meters per second. Next one, let's determine the following as a function of time. First, the kinetic energy of the box. K equals 1/2 mv squared. M is constant. V is a function of time. We simply substitute V into this equation to get K as a function of time. The net force acting on the box as a function of time. Net force equals to MA, and A is dV over dt. We know v as a function of time. We simply do the derivative of this expression relative to t. We can get net force. The derivative of this is just 3t. So it's m times 3t, m equals to 100. That gives us 300t. Next one, the power being delivered to the box. Power equals force times velocity. We know force as a function of time. We also know the velocity as a function of time. So we simply multiply the two expressions. You can simplify this expression to make it become 450 t cubed plus 600 t. Okay, now let's continue with this question. So for this question, we already figured out the velocity as a function of time, initial velocity, kinetic energy as a function of time, net force as a function of time, and the power as a function of time. Next two questions. Calculate the net work done on the box in the interval between t equals 0 to t equals 2 seconds. We know the net work done equals the change in kinetic energy. So we know kinetic energy as a function of time, so we simply plug it in at kinetic energy at 2 seconds, subtract kinetic energy at 0 second. So you should have 3,000 joules. That is the work done by the net force. Part D, indicate below whether the net work done on the box by the student in the interval would be greater than or less than or equal to the answer in part C. This is work done by the net force. We know students has to apply more force to do work. Why is that? That is because the surface is rough. So student has to work to overcome friction besides to increase the object's kinetic energy. So the answer to this is greater. The reason why is because the surface is rough. Some of the work done on the box by the student must be used to overcome friction. That's it. Thanks.